They could be different on each side, and they could be oriented in 8 different positions. And then you need 4 of them, so you need to collect 32 pills from some keys, which we didn't have. We need to find some other way, and that was China. Yeah. You go to China, there's people who do everything for you. You ask them for it, and it's not even very expensive. You get small, thin discs. In this case, 0.9 millimeter thick, diametrically magnetized from a very rare earth metal, whatever. And then you just put them together, and that's it, right? Not really, because the magnets will not want to go together in the wrong positions. So we had to order something new. We found that, first of all, we need to put something in between so they stick together. And then we found if this is like in 8 different positions, then maybe an octagonal magnet would be better. And yeah, they do that, no problem. So we have an app, yeah, and we need a template because you really cannot easily drill octagonal holes. We use some etching. Good enough we have in the Munich CCC workshop. There are some tools to etch stuff, of course, and I hope we can see this in the picture there. Well, what you can see there is the etched template. So this is 8 side holes, octagonal holes. You can see this magnetic fluid thing. You can see I think it's a North Pole finder, but whatever. And you can see round magnets, octagonal magnets, everything. This is a key for that system which opens a different lock. We just did some, let's say, privilege escalation on that. So yeah, this is, as you can see, open. Yeah, that's a still different key. In this case, there were no sliders but balls, and we didn't need to pick that. So yeah, you can see here this turns very well. And essentially you can see that key control on that lock is not what you thought it would be. 20 years ago, maybe yes, because it wasn't easy to get the magnets, but these days it's really difficult to have something which cannot be copied. So,
yeah. So, of course, we wanted to come back to our original idea of decoding the lock. And quite a while ago, we already built a magnetic coil system to manipulate the rotor. So we have something with some magnetic coils we can put into the lock, which is quite thin and everything is very, very small. And we were able to rotate the rotors electronically. And we also think we have an idea how we would find the gates. I don't want to talk about this in detail because it doesn't work yet. So possibly it will work, possibly it won't. We have problems with electronics because we need very high amps in the coil without burning it. So short pulses of the correct height to get the angles and the angles, and I think it was the angles and everything. But we're very optimistic that it might work someday. So watch out for new talks on this special topic. Possibly we'll also make it together or with some help from the tool guys. So if you also have ever worked on the magnetic code system and tried to do something with this, you're very welcome to join us at the lockpicking village and discuss in more detail what we tried and what we're going to try, or have any own ideas for this. But so far we can't really decode a lock without opening it, without seeing the key. But when we do, we know at least how to make the key. What you also can do with this key making, I think we didn't mention it, is of course you can have this privilege escalation thing. You can analyze different keys, you can see where the master keying is done and create a key with possibly the right combination for a master key. So really key control for this magnetic code system is gone.
Yeah, you don't even need to see the different keys, right? You just need to have one working key, and then you modify one position and see where the gates are and so on. So that's really a problem if you think you have something which can't be copied or modified. And that's now we have the conclusions, right?
I hope it's a bit slow here. What is he doing? Okay. So what is the main conclusions from our research? One, of course, is mechanical key security doesn't work. any mechanical key and an object you have in your hands, there is some way to copy it. No matter how complicated it is, the magnetic code system was the most complicated key we have encountered so far, at least the one everybody said it isn't doable, or many people said it isn't doable, and even that got copied, and it's not even very difficult when you have the right stuff. Actually, with our kit, or with our magnets and everything, it's easier to copy this key than a normal key where you have to file and anything. So, of course, electronics might work better. Because with electronics, you can easily revoke a key, it isn't valid anymore, and so the idea is, of course, electronic would be good. But one of the problems with electronic locks is that key manufacturers just don't understand how cryptography works. Everybody in the software industry knows a cryptographic algorithm has to be published so it can be tested, and it's really just safe if you can do this without breaking its security. Nobody would do online banking with an unpublished algorithm, but everybody has it in his electronic lock door. So really this is a problem why we don't trust any electronic locks, and we would recommend nobody to do so. And the locks often have other flaws. I think in the next session by Barry, you will hear some quite interesting things about this topic. So, oops, is there a slide missing? No, here it is. So to get to electronics lock, we, or especially HAR, started a project for open source electronic locks. The idea would be to have an hardware which anybody can build, or which is possibly also independent from the software, and then electronic, where you have different possibilities to access it, to open it, like a transponder or a token or anything. And realization of this idea already is in the Munich CCC headquarters for about a year now, where we have a door which is, it has a classical lock inside because we don't trust our electronics. So if it fails, we still have a lock. But we have never used it so far. We took the best one we found, but it's, who knows? Possibly one day we can remove it. But the usual way is to log into a wireless LAN and send an authentication with your mobile device. We basically use SSH in the moment, but with keys. But you could also easily add other stuff, and then a motor is activated, which we bought. It's an Airbus Homematic, from which we ripped all the wireless parts, because we don't trust it. We just use a motor. It's a nice thing you can add to a lock. But of course, the idea would be to find something with an electronic, with a mechanic you possibly can build yourself, or you can easily get from other parts. So if you would be interested in participating in this, visit the open source lock. It currently goes to the Lockpicking 101 forum, I guess, where there's a special section for the open source lock. So this might be an approach to get a lock where key control really works, and which you can trust besides that. So I think this would be the end of our presentation, at least if nobody has other remarks for it, and we would be open for questions.
Okay, questions. Who's got a question?
There must be one. Is there in the back? Yeah.
Have you tried Fields metal instead of Woods metal? Fields metal isn't as toxic, I believe.
We tried Roses metal and Woods metal. Fields metal we didn't try. I'm not sure about the physical properties of it. Do you know the melting point? Is it interesting for this application?
I think it's below 100 degrees.
Oh, okay. So we'll look into this. This sounds interesting. Thank you.
Okay. Marcus?
Hey, MH. My question was about the master lock. And I think you may have told this as part of the story in the village, but I've been kind of looped. Did you acquire that as a testing sample with their permission, just by knowing someone who had a sample, or did you just get it an early model? And do you think that groups like SSDev and Tool and others, do you think getting samples before they're published should just be part of the process?
Definitely it should be. Yeah, I just got that on a trade fair, the model of this new combination padlock.